Welcome students, let me continue another important concept, that is what derivatives here. See, this is also considered to be differentiation. Differentiation and one more concept is there in the calculus, that is what integration. These two are very fundamental concepts and these are the pillars of the calculus here. Now let me consider the function y is equal to fx. This is a real valued function defined over an interval I, which is a subset of R, where this function is defined over an interval I, which is a subset of real numbers. See, in this case x is independent variable and y is dependent variable here. If you substitute something to x, correspondingly y changes here. Okay. So in generally the variation of y with respect to x, that is what we can say the rate of change of y with respect to x, that itself is called the derivative here. So let us elaborate the concept here. Now if you take into consideration x here, a small change in this x, is represented. Suppose there is an increment, there is a change in x, say delta x is the increment here. So that a small change in the increment x is represented by the symbol delta x, we can say, or another symbol, this one is also used here, delta x. The change in x is represented as delta x here. So when x changes to delta x is changed to what here? X changes to x plus delta x. X is already there is an increment in it. Let me take into consideration delta x. Then there is a corresponding change in y. That change in y can be written as y changes to y plus delta y. Okay. Now with this change, the given function changes to what here? Y changes to y plus delta y. So x changes to x plus delta x here. X plus delta x I would like to write. And call this as equation number 1 and this one as equation number 2. Now let us take the difference of these two. Equation number 2 minus equation number 1. This gives what here? Y plus delta y minus y. This is the difference on left side. The difference on right side is f of x plus delta x minus fx here. And then further y and y cancels. So delta y is equal to what you are getting here, f of x plus delta x minus fx you get here. Now I would like to divide by delta x on both the sides here. Now what happens? Delta y divided by delta x, I would like to divide by delta x here. Delta x is equal to f of x plus delta x minus fx is there here. See, this is to be divided by delta x here. See, this ratio delta y divided by delta x gives you the rate measure. That is the rate of change of y with respect to x actually. See, applying at this stage, you applying limit as delta x tends to 0. Apply limit as delta x tends to 0 on both the sides. Then you see what happens. Both sides. See limit. This is limit delta x tends to 0. Delta y divided by delta x. This is equal to limit delta x tends to 0, f of x plus delta x, minus f of x whole divided by what we can say here, delta x. Please concentrate here. If this limit exists, on right side what we have chosen now, what we have taken, limit delta x tends to 0, f of x plus delta x minus fx divided by delta x. If the limit on right hand side exists, if this limit exists, then that value is called, then it is called the derivative of, then it is called derivative, this is called derivative of y with respect to x, with respect to x, and is denoted as, and is denoted as dy by dx, dy by dx. That means limit delta x tends to 0, delta y by delta x is conventionally represented as dy by dx, and hence on left side you can write dy by dx, and right side limit delta x tends to 0, limit delta x tends to 0, f of x plus delta x minus f of x, whole divided by delta x. So this is called the derivative of y with respect to x, dy by dx is equal to, now observe here, dy by dx is equal to what I have got here, limit delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x. This is what the dy by dx, derivative of y with respect to x here. Conventionally we take delta x is equal to h also. If delta x is equal to h, then dy by dx becomes, dy by dx is equal to limit, this delta x can be replaced by h here, so it is convenient to represent, so h tends to 0, f of x plus h minus f of x divided by delta x here, sorry, not delta x, this is h here, delta x is replaced by h now, so that's why you need to take h there, delta x is replaced by h here. So this is what the definition of dy by dx, derivative of y with respect to x here. See, when that is here at a particular point, it is in general, for a particular point, say x is equal to a, this derivative is defined in this manner, dy by dx at x is equal to a, this is given by limit h tends to 0, f of x is to be replaced by a, that is what, f of a plus h minus f of a divided by h here. So this is what the dy by dx at x equal to a. This can also be represented symbolically as in this manner, f dash of a is equal to limit h tends to 0, f of a plus h minus f of a whole divided by h. Okay, this is what h here, f of a plus h minus f of a divided by h here. See, one more convention we can give here. If you put a plus h is equal to x, then what happens? Then f dash of a is equal to limit, see, when h tends to 0, means when h is equal to 0, x equal to a, it means x tends to a, f of a plus x, that is replaced by x here, minus f of a remains as it is, divided by, this h can be replaced by h equal to, if you simplify for h here, see, this implies h is equal to what here, x minus a, so denominator becomes x minus a. So in this manner also we can take here, f dash of a equal to limit x tends to a, fx minus fa divided by x minus a. So in this manner also we can take here, this one also you need to remember here. So this is one thing, and then derivative of the function at x equal to a, f dash of a, this is defined in this manner, limit h tends to 0, f of a plus h minus f of a divided by h here. See, dy by dx, here this can also be represented as d by dx of y, or this can also be represented as f dash of x, this can also be represented as y dash, sometimes it is represented by y1 also. So these are the different notations, or you may represent it as dy by dx of y means f of x. So that's why dy by dx of f of x also. So these are the different notations for derivatives. Sometimes derivative of the function y, capital D we write and then we write. This is also the notation rarely used here. But these are the standard notations for the derivative of the function here. So this is what the concept of derivative. Derivative means the rate of change of y with respect to x. The rate measure, it is nothing but the rate measure here. So the variation of the dependent variable with respect to independent variable. So that variation is explained by the concept of limit here, by the concept of derivative, and this is nothing but simply the limit here. So this differentiation of y at x is equal to a or fx at x equal to a, it means what here? Limit h tends to 0 a plus h minus f of a divided by h. Alternative form, limit x tends to a fx minus f of a divided by x minus a here. That means the left hand limit and right hand limit of this expression must exist here. Whatever the left hand limit exists, that is called left derivative, and whatever the right hand limit exists, that is called the right derivative here. So anyhow, so this is what the introduction to the concept of derivative here. So derivative of the function dy by dx is equal to limit h tends to 0 f of x plus h minus f of x divided by h. This one you need to remember. Next to that, derivative of the function at x equal to a is given by limit h tends to 0 f of a plus h minus f of a divided by h here. And this is what the alternative form. If you want to avoid that h tends to 0, then x tends to a, at that time f of x minus f of a divided by x minus a will get here. And these are the different notations for this. Now let me consider some examples. And one more thing I would like to introduce at this stage itself here. Finding the derivative of the function by this method, whatever the method is there now here, dy by dx equal to limit x tends to 0 f of x plus h minus f of x divided by h, using this formula. So this is called first principles method. Finding the derivative of the function by using this procedure, this is called first principles method here. Now let me find out the derivative of some functions here. Let us take the examples. Now let me consider a few examples here. See, let us take example number 1 here. Some solved examples I would like to take from your text here. Find the derivative of fx equal to 10x. Find the derivative of fx is equal to 10x. So this is what the problem here. Now let me take into consideration the function fx is equal to y is equal to, or you may take fx is equal to, what is that here, 10x. This is what the function, given function. Now just recall the definition of dy by dx. Dy by dx is equal to limit h tends to 0 f of x plus h minus fx divided by h. So this is your basic definition. I would like to apply the same definition to evaluate the derivative of the function fx equal to 10x here. See, limit h tends to 0, you write as it is. Limit h tends to 0 f of x plus h. See, fx is equal to 10x. So f of x plus h is equal to 10 into bracket x plus h. That's all. X is to be replaced by x plus h. This is 10 into bracket x plus h. Minus fx is nothing but simply 10x. Write 10x here. Whole divided by h here. Let us simplify this limit. Evaluate this limit here. So limit h tends to 0. 10 into x is 10x plus 10h minus 10x whole divided by what? H here. See, direct evaluation is not possible. If you put directly h equal to 0, take 0 by 0. Now on simplification, you see what happens. This 10x and this 10x cancels. So this is equal to, here only I would like to complete the solution here. This is equal to limit h tends to 0, what remains we see here? 10h upon h remains. 10h upon h. So h cancels. What remains? Limit h tends to 0. Only 10 remains. 10 is a constant, so its answer is 10 only. So the derivative of fx equal to 10x is 10. Therefore, dy by dx is equal to 10, or f dash of x is equal to 10. Actually, there is a formula x to the power n. That formula, if you apply, it is very within a fraction. We can say the answer is 10. But at the initial level, by the first principles method means you have to follow this way. So beginning ಹೇಗೆ ಕಲಿತೀವಿ ನಾವು, ಮುಂದೆ ಹೋಗಿ ಸ್ವಲ್ಪ ಇನ್ನೂ ಫಾರ್ಮುಲಾ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಆದಮೇಲೆ ನೇರವಾಗಿ ಟರ್ಮ್ ನೋಡಿದ ತಕ್ಷಣ, ಆಲ್ಜಿಬ್ರಾಕ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನೋಡಿದ ತಕ್ಷಣ ಇದ್ರ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಏನಂತ ಹೇಳಲಿಕ್ಕಾಗತ್ತೆ, ಇದರ ಡೆರಿವೇಟಿವ್ ಏನಂತ ಹೇಳಲಿಕ್ಕಾಗತ್ತೆ. So let us take the next example. Another example here, second one. Let me take into consideration the textual example. X square he has taken here. Find the derivative of x square. Derivative of x square. Actually x raised to n ಗೆ ಒಂದು ಫಾರ್ಮುಲಾ ಇದೆ, nx raised to n minus 1 ಅಂತ. ಅದರ ಪ್ರಕಾರ 2x raised to 2 minus 1, 2x ಆನ್ಸರ್ ಬಂದ್ಬಿಡ್ತದ. ಇದು ಆನ್ಸರ್ 2x ಅಂತ ನಾನು ಈಸಿಲಿ ಹೇಳ್ತೀನಿ ನೋಡಿದ ತಕ್ಷಣ ಓರಲ್ಲಿ. ಬಟ್ ಫಸ್ಟ್ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ನಿಂದ ಮಾಡಬೇಕಂದ್ರೆ, ಡೆಫಿನೇಷನ್ ಯೂಸ್ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕಂದ್ರೆ ಹೀಗೆ ಮಾಡಬೇಕು ನಾವು. ಸೊ ಲೆಟ್ ಮಿ ಟೇಕ್ ಇನ್ ಟು ಕನ್ಸಿಡರೇಷನ್ fx is equal to x square here. So this is the given function. F dash of x is equal to, or dy by dx is equal to, limit h tends to 0, f of x plus h minus f of x whole divided by h. This is your basic definition. Apply that definition here. Limit h tends to 0. Here only I would like to continue. Limit h tends to 0, you write f of x plus h. X is to be replaced by x plus h. So x plus h bracket square it is, x plus h to the power 2 minus x square here. Fx means x square whole divided by h as it is. Fx means x square. F of x plus h means x is to be replaced by x plus h. x ಅನ್ನ x plus h ನಿಂದ ಬದಲಾಯಿಸ್ಕೊತೀರಿ, ರಿಪ್ಲೇಸ್ ಮಾಡ್ಕೊಂತೀರಿ, ತುಂಬ್ಕೊಂತೀರಿ. ಅವಾಗ ಏನಾಗುತ್ತದು, f of x plus h ಅಂದ್ರೆ ಏನಾಗ್ತದ, x plus h to the power 2 ಆಗ್ತದ. ಇದು ಯಾವ ರೀತಿ ಬದಲಾಗತ್ತಿರೋ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಬೇಕಷ್ಟೇ. So this is equal to limit h tends to 0, limit h tends to 0. Expand that by using the formula a plus b whole square. So this is x square plus 2hx plus h square. A square plus 2ab plus b square. Next minus x square whole divided by what we can write here, h you can write. Now it is the time to eliminate plus x square and then minus x square. This is equal to limit h tends to 0, limit h tends to 0. 2hx plus h square is there. From that we take common h. By taking common h, 2x remains plus h remains. 2x plus h whole divided by h here. So h cancels. So this is equal to what remains finally? Limit h tends to 0. 2x plus h remains here. 2x plus h. h tends to 0. Put that 0 here. 2x plus 0. So its answer is 2x only. What equal to? F dash of x equal to. Therefore, derivative. Therefore, my conclusion is dy by dx is equal to, or f dash of x is equal to, this is equal to what here? The f dash of x equal to 2x. It means derivative of x square, dy by dx of x square is equal to 2x. This is what the answer. d by dx means derivative, differential coefficient. We call that as differential coefficient. d by dx of x square is equal to 2x. Derivative of x square with respect to x is 2x. Differentiation of x square is 2x. That's all. So ಈ ರೀತಿ ಇದನ್ನ ಅರ್ಥೈಸ್ಕೊಳ್ತೀವಿ. ಸೊ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ಗೆ ಹೋಗೋಣ. Let me continue the third example. See, I would like to take into consideration another example, very simple example. 1 by x you take here. Find the derivative of 1 over x. Find the derivative of 1 by x. Find the derivative of 1 by x. 1 upon x. The function itself in this case, the function itself, fx itself is nothing but what here in this case, 1 by x. By our definition, dy by dx is equal to, or f dash of x is equal to, limit h tends to 0, f of x plus h minus fx divided by h. This is your basic definition. Let us apply that. Limit h tends to 0. This is equal to limit h tends to 0, f of x plus h. Can you tell me anybody what to write f of x plus h? fx is given by 1 by x. What to write f of x plus h? ಹೇಳ್ತೀರಾ ಯಾರಾದರೂ? ಥರ್ಡ್ ಎಕ್ಸಾಂಪಲ್ ಬಂತಿದ್ದು ಹೇಳ್ಬೇಕು ನೀವೀಗ. fx is 1 over x. So what about f of x plus h? Come on. ಆಗೋದಿಲ್ಲ ಹೇಳಕ್ಕೆ? ಸುಮ್ಮನೆ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ಬೇಡ್ರಿ, ಹೇಳ್ರಿ. ದಿವ್ಯಾ ಮಾತಾಡು. ಹಾ, ನೋಡಮ್ಮ ಇಲ್ಲಿ ಸ್ಕ್ರೀನ್ ಕಡೆ ನೋಡು, ಮಾತಾಡು, ರೆಸ್ಪಾಂಡ್ ಮಾಡಿದಕ್ಕೆ. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 1 by x ಇದೆ. ರೀಪ್ಲೇಸ್ ದಿಸ್ ಎಕ್ಸ್ ಬೈ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್. ಏನಾಗಬೇಕು ರೈಟ್ ಸೈಡ್? ವಾಟ್ ಇಟ್ ಶುಡ್ ಬಿ ದೆನ್? 1 upon ಎಕ್ಸ್ ಅನ್ನ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್ ನಿಂದ ರೀಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಬಲಗಡೆ ಏನಾಗಬೇಕು? 1 upon ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್ ಆಗ್ಬೇಕಾ ಇಲ್ಲ? ಮತ್ತೆ ಇದನ್ನ ಹೇಳಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತೊಗೊಳತ್ತೀರಿ ನಾವು? ಎಷ್ಟು ಸಮಯ ತಗೊಳ್ತಾ ಇದ್ದೀರಿ ಇದನ್ನ ಹೇಳಲಿಕ್ಕೆ? ಪಲ್ಲವಿ, ಪಲ್ಲವಿ ಮಾತಾಡೋ. ಈಗ ನೋಡಮ್ಮ, ಎಫ್ ಎಕ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಕ್ಸ್ ಕ್ಯೂಬ್ ಐತ ತಿಳ್ಕೊಂಡು, ಅವಾಗ ಹೇಳ ನಂಗೆ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್ ಎಷ್ಟು ಬರಿಬೇಕು? ಹಾ, ಮತ್ತೆ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್ ಟು ದ ಪವರ್ 3. ಇಷ್ಟಾಕೆ ಮತ್ತೆ ರೆಸ್ಪಾಂಡ್ ಮಾಡ್ತಾ ಇಲ್ಲ ನೀವು? ಈಗ ಜೋರು ಮಾಡಿದ್ಮೇಲೆ ಉತ್ತರ ಕೊಡ್ತೀರಿ. ಏನು ಇವ್ರಿಗೆ ಯಾಕೆ ಉತ್ತರ ಕೊಡ್ಬಾರ್ದು ಅಂತೀರೋ? ಇವ್ರಿಗೆ ಯಾಕೆ ಕೊಡ್ಬೇಕಂತೀರೋ? ಹಾಂ, ನಿಂದೇನಲ್ಲ ಲಾಜಿಕ ತಿಳಿವಲ್ದ. ಹೇಳ್ಬಲ್ಲ ಈಗ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್ ಕೊಟ್ಟು ಏನು ಬರಲಿ? ವಾಟ್ ಶುಡ್ ಐ ರೈಟ್? ಒನ್ಸ್ ಅಗೇನ್ ರಿಪೀಟ್ ಇಟ್. ಹಾಂ, 1 upon x plus h minus fx ಅಂದ್ರೆ ಏನು ಬರೀಬೇಕು? ವಾಟ್ ಐ ಶುಡ್ ರೈಟ್? fx 1 by x ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ h here. ಹಂಗೆ ಮಾತಾಡ್ತಾ ಇರ್ನಿ, ಬಾಯ್ ಬಂದ್ ಮಾಡಬೇಡ ಅಂದಿಟ್ಟ. ನಾ ಕೇಳಿದ ಉತ್ತರ ಕೊಡು. ಲಿಮಿಟ್ h tends to 0, limit h tends to 0. In the numerator, see this is h as it is. Take LCM there. LCM ತಗೋ. ಏನಾಗತ್ತೆ LCM ಹೇಳು? ಆ ಡಿಫರೆನ್ಸ್ ಐತಲ್ಲ, ಅದು ಡಿನಾಮಿನೇಟರ್ ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡೋ LCM ಏನಾಗುತ್ತಾ? ಎಕ್ಸ್ ಇಂಟು ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್. ಓಕೆ, ನ್ಯೂಮರೇಟರ್ನಾಗ ಎಕ್ಸ್ ಈ ಕಡೆ ಗುಣಾಕಾರ ಆಯಿತು, ಮೈನಸ್ ಎಕ್ಸ್ ಮೈನಸ್ ಎಚ್ ಆಯ್ತು. ದಿಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಲಿಮಿಟ್ ಎಚ್ ಟೆನ್ಸ್ ಟು 0. ಲಿಮಿಟ್ ಎಚ್ ಟೆನ್ಸ್ ಟು 0. ಕಾನ್ಸಂಟ್ರೇಟ್ ಹಿಯರ್ ಕೇರ್ಫುಲಿ. ಎಕ್ಸ್ ಆ್ಯಂಡ್ ಎಕ್ಸ್ ಕ್ಯಾನ್ಸಲ್ಸ್, ಮೈನಸ್ ಎಚ್ ರಿಮೈನ್ಸ್. ಮೈನಸ್ ಎಚ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಕ್ಸ್ ಇಂಟು ಬ್ರಾಕೆಟ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಚ್ ಆ್ಯಂಡ್ ದೆನ್ ಇಂಟು 1 by h, ರೈಟ್? ಅದು ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಚ್ ಐತಲ್ಲ, ಅದನ್ನ ಹಿಂಗೆ ಬರೆದ್ಬಿಡ್ರಿ, 1 upon h ಅಂತ ಬರೆದ್ಬಿಡ್ರಿ. ಸೊ ಆಸ್ ಅ ರಿಸಲ್ಟ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ದಿಸ್ h and h cancels. This is equal to limit h tends to 0. h cancels, in the numerator minus 1 remains divided by x into bracket x plus h. If you substitute h is equal to 0, evaluate, no direct evaluation. Minus 1 divided by x into bracket x plus 0. h tends to 0 means x equal to 0 that I have substituted. h tends to 0 ಏನಿದಿಲ್ಲ, ಈ ಹಂತಕ್ಕೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ನಿಂದ ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಲಿಮಿಟ್ ಅನ್ನು. h tends to 0 ಅಂದ್ರೆ ಏನಾಗ್ತಾರೆ? h equal to 0 ಹಾಕ್ತೀರಾ. ಸೊ ದಿಸ್ ಇಸ್ equal to what you are getting? minus 1 by x square you are getting. So the answer is d by dx of f dash of x is equal to what we got now? minus 1 by x square we get. d by dx of 1 by x is equal to minus 1 by x square. ಆ್ಯಕ್ಚುಲಿ ಮುಂದೆ ಹೋಗಿದ್ದು ಒಂದು ಫಾರ್ಮುಲಾ ಅಂತಾನೆ ಯೂಸ್ ಮಾಡ್ತೀರಿ ನೀವು. ಡೆರಿವೇಟಿವ್ ಆಫ್ 1 by x is minus 1 by x square ಅಂತ ನೇರವಾಗಿ ಯೂಸ್ ಮಾಡೋದನ್ನ ರೂಢಿ ಮಾಡ್ಕೊಂತೀರಿ ಮುಂದೋಗಿ. ಸರಿ, ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್. ಸ್ವಲ್ಪ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎ ಮೇಲೆ ಒಂದಿಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ತೊಗೊಳ್ತೀನಿ ನೋಡ್ರಿ. Now let me take into consideration another example. Find the derivative of at x is equal to 2 of the function fx equal to 3x. Means you need to find, what we need to find here? To find the derivative of the function at x equal to 2 means f dash of 2 you need to find out here. Now you recall the formula f dash of a. f dash of a means the derivative of the function at x equal to a is given by limit h tends to 0, same. But f of x plus h ಅಲ್ಲ ಇಲ್ಲಿ, f of a plus h minus f of a whole divided by h. This is what the concern formula. Let us substitute the values here. This is equal to limit h tends to 0, h tends to 0, f of a plus h, that is nothing but f of a plus h is equal to 3 into bracket x is to be replaced by a plus h. So a plus h minus f of a is nothing but 3 into one minute. See what we need to find out here. F dash of 2 you need to find out. A is to be replaced by 2. Now only you take here 2. This is limit h tends to 0. F of 2 plus h. A is replaced by 2 minus f of a, that is nothing but 2 whole divided by h here. Now let us substitute the values in the given function. Limit h tends to 0. F of x is given by 3x. So f of 2 plus h is given by 3 into bracket 2 plus h minus f of 2 x is to be f of 2 x adala if x equal to 3x ali x idal 2 hakri. So 3 into 2 you are getting here. So whole divided by h we can add. So simplify this. This is equal to limit h tends to 0. Sorry, here only I would like to complete. This is equal to limit h tends to 0. 3 into 2 is 6 plus 3h minus 6 whole divided by h. 6 and 6 cancels. What remains? Limit h tends to 0 remains 3h by h. 3h upon h. H cancels. What remains? 3 remains. H cancels. 3 remains. 3 is a constant. So limit x tends to a k equal to k only. According to that, you write 3 only. So this is what the answer for this question. Answer is 3. So limit h tends to 0, 3 equal to what here? 3 only here. Another similar example, let me take into consideration here. Find the derivative of fx equal to 2x square plus x at x equal to minus 1 here. Now f dash of a is given by limit h tends to 0, f of a plus h minus f of a whole divided by h. This is what the basic formula. F dash of minus 1 you need to find out. F dash of minus 1. So this is equal to limit h tends to 0. F of a is to be replaced by minus 1 plus h minus f of a. A is minus 1 whole divided by h. Now this is equal to limit h tends to 0. F of minus 1 plus h. ಲಿಂಬಿ ಗಿಡದ ಹೇಳೋ ಎಫ್ ಆಫ್ ಮೈನಸ್ 1 ಪ್ಲಸ್ ಎಚ್ ಹೇಳಕ್ ಸಾಧ್ಯ ಆಗತ್ತೆ ಮನಿಂಗ ಸೃಷ್ಟಿ ಹೇಳ್ತಿ ರಾಧಿಕಾ ವಿಶಾಲ್ ಯಾರಾದ್ರೂ ಹೇಳ್ಬೋದು ಎಫ್ ಎಕ್ಸ್ ಇಸ್ ವೆರಿ ಕ್ಲಿಯರ್ ನಾವು 2x square plus x f of minus 1 plus h f of minus 1 plus h ಇದನ್ನ ಹೆಂಗಂತ ಅರ್ಥ ಮಾಡ್ಕೊರಿ ನಾವು minus 1 plus h ಇದು ಈಸಿ ಅಂದ್ರೆ f of h minus 1 ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದು ಈಸಿ f of h minus 1 x ಇದ್ದಲ್ಲಿ h minus 1 ರಿಪ್ಲೇಸ್ ಮಾಡ್ರಿ ಇಲ್ಲಿ ಮ್ಯಾಲ್ ನೋಡ್ರಿ x is to be replaced by h minus 1 so what to write
2 into h minus
2 into bracket s correct h minus 1 bracket square plus h minus 1 plus h minus 1 ಈಗ ಏನು ಬರೆದ್ರಿ ನೀವು f of h minus 1 ಬರೆದ್ರಿ minus f of minus 1 ಬರಿಬೇಕಲ್ಲ that is nothing but you put a bracket here ಬೇಕಂದ್ರೆ ಇಲ್ಲೊಂದು ಬ್ರಾಕೆಟ್ ಹಾಕೊಂಡ್ಬಿಡ್ರಿ so first f of minus 1 plus h ಮುಗೀತು ಈಗ minus f of minus 1 x is to be replaced by minus 1 so 2 into minus 1 to the power 2 plus of minus 1 okay whole divided by h ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೋಬೇಕು ಈಗ ಲಿಮಿಟ್ h ಟೆನ್ಸ್ ಟು 0 ನೋಡ್ರಿ ಭಾಳ ಇಲ್ಲಿ ಸ್ಟೆಪ್ ಸ್ವಲ್ಪ ಡೆಲಿಕೇಟ್ ಇದೆ ಇದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ಬೇಕು ನಿಮ್ಗೆ ಇದು ಹೇಗೆ ಅಂತಂತ ಇನ್ಮೇಲೆ ಇದನ್ನು ಸುಲಭೀಕರಣ ಮಾಡೋದಿದೆ 2 into bracket expand by using the formula a minus b whole square h square minus 2h plus 1 plus h minus 1 remove the bracket close and then yes it is correct h square minus 2h plus 1, 2 outside ಇದೆ, plus h minus 1, you put the bracket at this moment, minus of bracket, minus 1 whole square is 1 only, 2 into 1 is 2 only, plus into minus minus 1, whole divided by h. Let us simplify this. ಇದಕ್ಕೆ ಆನ್ಸರ್ ಎಷ್ಟು ಬರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಆಗಲೇ -2 ಬರಬೇಕು. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಕಂಟಿನ್ಯೂ. ಲಿಮಿಟ್ h tends to 0, this is equal to limit h tends to 0, concentrate here, 2 into h square minus 4h plus 2, 2h square minus 4h plus 2, 4h plus 2, 2h square minus 4h plus 2, correct it is, plus h minus 1, plus h minus 1. Next, minus, see, plus h minus 1 you have written, 2 minus 1 is 1 only, backside minus hand, so minus 1, one more minus 1, whole divided by h. Simplify this. This is limit h tends to 0, 2h square minus 4h plus h, this leads to minus 3h, 2 plus 2 and then minus 2, whole divided by h. Plus 2 minus 2 cancels. This is limit h tends to 0, eliminate plus 2 and minus 2, take h common from the numerator. If you take h common, 2 remains, one of the h is taken, h remains, minus 3h, h is taken, 3 only, whole divided by h. Now h and h cancels. Indeterminate form ಗೆ ಲೀಡ್ ಆಗ್ತಕ್ಕಂಥ ಫ್ಯಾಕ್ಟರ್ ಹೋಗ್ಬಿಡ್ತೀಗ. Evaluate now. Limit h tends to 0, 2h minus 3. So this is equal to h is tending to 0. h is tending to 0. -3 ಬರಬಾರ್ದಾಗಿತ್ತಲ್ಲ ನನ್ನ ಪ್ರಕಾರ. ಎಲ್ಲರೂ ತಪ್ಪಿರ ನೋಡ್ರಿ. 2h ಸ್ಕ್ವೇರ್ minus 3h ಕರೆಕ್ಟ್ ಐತಿಲ್ಲ ನೋಡ್ರಿ. minus 4h plus h. ಒಂದು ನಿಮಿಷ ಹಿಂದೆ ಏನಾರ ಬಿಟ್ಟರೆ ನೋಡ್ರಿ ಟರ್ಮ್ಸ್ ಇಲ್ಲ. 2 is applicable to x square itself. Yes, correct ಇದೆ ನೋಡೋಣ. So this is equal to h tends to 0. So the answer is -3 only. 2 into 0 minus 3, which is equal to -3. Okay. So this is what the solution for this example.